Hi, and welcome to the Week 3 Deepen Your Learning PowerPoint. This week, we're going to be talking about redshift, blueshift, and the electromagnetic spectrum. So we need to focus on that last term first to give context to redshift and blueshift. This is the electromagnetic spectrum here. It's a measurement of energy that can be emitted by objects. There is a huge range of energies that can be emitted. Some of the things that have higher frequency or a lower wavelength, so that means that the waves are closer together, are things like X-rays or UV rays. Things with a lower frequency and a larger wavelength, so a bigger space in between the waves, are things like microwaves or radio waves. The part that we're going to focus on is the visible light spectrum, which is a very small section of the electromagnetic spectrum, and it's magnified down below. The point that's important here is that purple is on the left, which means that it is a higher frequency, and the red is on the right, which means that it is a lower frequency. Now, in terms of cosmology, to put this into context, we're going to look at energy that's emitted by stars, and specifically, we're going to look at how we can measure that energy with visible light. Now, we're going to connect this point with this next one, so let me talk about this first, and we'll circle back to that. The next one is the Doppler effect. So this is also about waves, like we just saw with the electromagnetic spectrum. This effect is something that you're familiar with probably in sound. The same thing happens with visible light, like we were just talking about. But in terms of sound, you have probably heard this when you hear, for example, an ambulance or a police car coming towards you and then driving away. You'll notice that the pitch seems to change. As the pitch changes, when it's coming towards you, it'll sound like the pitch is getting higher and higher, and as it moves away from you, the pitch will sound lower. The reason for that is as the ambulance moves towards you, the waves are getting compressed, so they have a higher frequency, which translates to a higher pitch. As it moves away from you, the waves are stretched out, which means they have a lower frequency or a lower pitch. Now, again, the same thing can happen with light. So in the image here, as a light moves towards you, the waves will be compressed, which have a higher frequency. And as the light moves away from you, the waves will be stretched, which has a lower frequency. If we go back here, we can remember that purples and blues have a higher frequency, whereas reds have a lower frequency. What that means is as objects move towards me, they will shift towards the blue light, and as objects move away from me, they will shift towards red light. So that is termed blue shift and red shift. So this pink object here is moving to the right. If we were standing to the right of this pink object, say it's a star, if we were to the right of this star and the star was moving towards us, the light waves that are being emitted by the star would get compressed and they would become more blue. So they would blue shift. Instead, what we actually observe when we're looking at other stars in the universe is that they are red shifting. The stars are moving away from us. The light waves are being stretched out and they are red shifting. So they are moving towards the lower frequency, larger wavelength side of the electromagnetic spectrum. If you have any additional questions about the electromagnetic spectrum, blue shift or red shift, please don't hesitate to reach out to me.